Okay, antiderivatives and indefinite integration. Okay, I guess first we should talk about the prefix anti. Right, usually anti means against, right? Like you're against, you're anti. Gosh, the first word that came to your mind was political. I don't want to say that one. You're anti some party or some position, but we're not against derivatives. I mean, you might be against derivatives, but I hope you're not anti-derivative in that sense of being anti. But anti also means opposite. So this is the opposite of derivatives. We're going to be going backwards. We're going to be underivatizing, and I'll use all sorts of made-up words to remind us what antiderivatives are. Underivatives, backwards derivatives, like we're just thinking backwards. It's sort of like, I guess Jeopardy is still on. Right? Jeopardy is they give you the answer and you got to come up with a question. That's kind of what antiderivatives are. It's like, here's the answer. Where did that come from? What was the original function if the derivative is this? So up until now, I gave you the function and asked for the derivative. This unit is, here's the answer. What was the function whose derivative is this? So again, if you know the forward rule, it's a whole lot easier to go backwards. The analogy I like to use is driving. Right? If you can drive forward, you can drive backwards, but it's definitely harder driving backwards. Like you got to slow down and be super careful because it's reversed and you may have a backup camera, but you don't want to hit the mailbox on the way out. Usually someone laughs because they've done that. I hope none of you have. Like the better you are driving forward, the easier it'll be going backwards, but you still got to go slow going backwards. That's the warning for today. Like you can do this, but slow your brain down. Do not race through these because we're in reverse, so we have to be careful. Okay, we know that if f of x is 2x cubed, then f prime of x is 6x squared. Yeah, that's the power rule. Bring the 3 down, decrease the power by 1. Got it. But what if we are given like the opposite information? We are given that the derivative is 4x cubed, and we want to go backwards to figure out what was the function. So the math term for that is the antiderivative of 4x cubed, the underivative of 4x cubed. So what can you think through that one? That one's pretty straightforward. X to the fourth. If I take the derivative of x to the fourth, I would get 4x cubed. We can say then that the antiderivative of 4x cubed is x to the fourth. Is there any other function whose derivative is 4x cubed? Oh, that's kind of weird. Is there anything else? And the answer is yes. Is there any other function whose derivative is 4x cubed? There's a type of thing whose derivative is 0, so it's hard to go backwards. If your answer is 0, you don't know like where that came from. Who has a derivative of 0? Constants. So like x to the fourth plus 7, that derivative would be 4x cubed. X to the fourth minus 351, that derivative would be 4x cubed. So you can add or subtract any number you like. Thank you. Oh, let me get you this. You can add any constant you like, because when you take the derivative of a constant, it goes away. We can add any constant to your antiderivative and get another function whose derivative is 4x cubed. And that any constant we label C, the constant of integration. So our best answer then is x to the fourth plus c. Plus c will be some of your nemesis for the rest of the year. When you do an antiderivative, don't forget to put the plus c on there. And in fact, that's why it's called indefinite integration, because I don't have a definite answer. I've got a plus c at the end of this thing. So I don't have an exact answer yet. Like they can give us information where we can find c, but right now I don't know what it is. Just plus c. Fair? Oh yes. So go backwards. Don't forget the plus c. All right. The next section is just about notation, like how we communicate that we're taking an antiderivative. We denote antidifferentiation, antiderivatives, with an integral sign. So it's like an elongated S, and we'll talk later why it's an elongated S. You take an S and you stretch it out, stretch it way out, it looks like that. Again, why that is, we'll get to later, next week, but later. So how we ask for, rather than just say, type it out, find the antiderivative of, we use that integral sign. So the integral of 4x cubed dx, that just tells us which variable to use. It'd be x to the fourth plus c. So if g is an antiderivative of f of x, then the antiderivative of f of x is g of x plus c. Plus c, plus c, plus c. Don't forget the plus c. The antiderivative of f of x with respect to x is equal to g of x plus c. That's just typing it out, like how to say that. Okay, things to know, and I would preface that with, you kind of already know. Right? If you know how to drive forward, then you kind of know how to drive backwards. We need practice. We need lots of practice. But we know how to drive forward. These are our backwards driving rules. Power rule for integrals. Okay, if n is any real number except -1, then the antiderivative of x to the n, you know what, Braden, you're doing a great job over there. Let's use the old rule first. Let's use the derivative rule, remind ourselves what that is, and then we'll see if we can use that rule in reverse. So the derivative of x to the n, bring the n down, decrease the power by 1. Right, you've done that probably 100 times by now. Maybe more. Now we want to use that rule in reverse. We want an antiderivative x to the n. So we'll increase the power by 1. Right, rather than decreasing it by 1, we're going to increase it by 1 because we're doing the opposite. And now instead of multiplying by n, we're going to divide by the new exponent. The old way, the derivative way, is to decrease the power by 1 and multiply by the old exponent. So the opposite of multiply is divide, the opposite of old is new, and the opposite of decrease is increase. Everything is reversed. We're going backwards. Some of you will do this very mechanically, you'll have to think, all right, increase by 1, divide by the new exponent. That's fine. Others of you will do it sort of like we did up here. You just look at it and kind of figure it out. Like we hadn't even talked about a rule up here. You just kind of figured out what would work. And that's going to happen a lot. Like if you're really good at driving forward, then you can drive backwards just kind of by feel. But when you're just learning, you're thinking about if I turn the wheel this way, then my wheels do that, and I go that. That's okay. Hopefully you get to where it's a little bit smoother, but that's why we're going to have lots of practice. Right there on top of the chair. Yep. Okay, more stuff you already know. The antiderivative of cosine. So think, who has a derivative of cosine? Sine. And then don't forget the plus c. Okay, this one's a little bit trickier. Who has a derivative of sine? How do I go backwards from sine? Negative cosine. Who has a derivative of secant squared? Hold on, don't call it out loud. Let me pick on somebody for that one. These are rules that we kind of know. Right, Maddie? Who has a derivative of secant squared? Tangent does. Tangent of x plus c. So, Laura, you can follow Maddie's example, although it's not exactly the same. Who has a derivative of cosecant squared? Good. Negative cotangent of x plus c. Tristan, a harder one, but we're also running out of trig functions here. Who has a derivative of secant tangent? We got to know, we should recognize that as being the derivative of one of our trig functions. It's secant. Like I said, we're running out of choices here. The derivative of secant is secant tangent. So, Elizabeth, the antiderivative of cosecant cotangent? Negative cosecant. So, usually we heavily star the things that you have to memorize. I don't think these should be heavily starred. Right? Because I don't think this is a memorized situation. I think you already know those. You just have to put your brain in reverse to figure them out. So rather than taking up memory storage in your brain, use your brain to figure out how to go backwards. Okay, let's get some practice on these. The good news, by the way, is that next page we're not going to do until next Thursday, notes-wise. So after we get through this page of notes, it's a whole bunch of days of practice. Right? Now you think about, you still don't drive backwards very often. We're going to drive backwards a lot. It's tricky driving backwards, even if you've been driving for 30 years. You got to be careful. We're going to take lots of time to drive backwards, and that's what this is thinking backwards. Okay, so 8x cubed. I don't think I want to just figure that out. I think I'm going to use the formula for now. So I'm going to increase the power by 1. That gets me to 4. The 8's still there. And divide by the new power. Now that can simplify. It's also a safe stop, so I don't even have to simplify it. But that's a good start for now. Increase the power by 1. Divide by the new power. So, how about, I'm going to just leave the 9 there. Caden, what do I do with x squared? What would the antiderivative of x squared be? Yep. But finish that thought. Divide by 3. And again, we'll simplify that in a minute. Okay, just the constant. That one looks weird because wait a minute, I'm supposed to increase the power by 1, but there's not really a power there. So for that one, most of the time students just think, wait a minute, I know who has a derivative of 4. I bet Barrett knows who has a derivative of 4. 4x. Now, the formula still works. It's just a little bit weird. You could rewrite that as 4x to the 0, and then your rule works. You could, right, 4 is the same thing as 4x to the 0. Increase the power by 1, divide by 1, and you get 4x. But most people don't use the formula for that one. They're just like, oh, if something has a slope of 4, well, that means the line would have been 4x. And then what's not quite right about that answer? Plus c. And I suppose we should simplify to clean things up. Okay, that next one, that looks like, remember when we take derivatives of this, we don't like derivatives of roots. We would like derivatives of powers. Same thing with antiderivatives. So, Marie, don't take an antiderivative. Just tell me how to rewrite the fourth root of x cubed. Good. That's going to make an antiderivative a lot easier. Still got to be careful, but I can do that now. Hector, what's the antiderivative of x to the 3/4? Increase that by 1.
So, is that 7/4?
Good. You've got a hard one.
Yeah, there's something in the front, but...
There's something in the front.
Yeah.
I want to divide by 7/4. But I don't really want to write over 7/4. What would be the same thing? What could I multiply by that would accomplish the same thing as dividing by 7/4? 4/7. Oh, I didn't even mention this. Most of the time, students are checking these as they go. Right? So if I wanted to check this, I could work backwards. 7/4 times 4/7 cancels each other out. Decrease 7/4 by 1, and I've got x to the 3/4. So like, you'll know if you got them right because you're just going to check them. Should have checked this first one. Like, taking a derivative is easy. So like, write it forward, and that would be 8x cubed, 9x squared, plus 4. So super easy to check them. Just a little trickier going backwards. Graham, how about the antiderivative of 1? Yep, so plus x. And then Ryan, why is my answer not complete? I need a plus c. Number 3. I don't like number 3 because I don't like that in the bottom. So, Will, how could I rewrite that to make my life a little easier? Yes. This will be one that people miss, not because they don't know what they're doing, but because they think they know what they're doing. Like, they'll try to do that in their head, and they'll end up messing things up. So, at least for the first 100 times you do this problem, write it out. Because then when you increase the power by 1, Cody, what happens if I increase the power by 1 from negative 7? Good. Divided by, right, increase the power by 1 and then divide by that new power. Divide by the new power. Divide by negative 6. Plus c. That's an okay safe stop. Multiple choice is going to clean that up. It'll be negative 1/2. And they might even put x to the 6th in the bottom. Again, either one's okay, but multiple choice is going to clean that up. That's probably, for now, the most missed question, because people look at x to the 7 and they're like, oh, increase the power by 1. 7 goes up to 8. Well, yes, 7 plus 1 is 8, but that was a negative 7 down there. So be careful. Number 4. I'd be mean to pick on someone for number 4. Thoughts on number 4? On what we should do first on number 4? we did this first step when we first started doing derivatives, and before we knew the chain rule. Like, this looks like a chain rule kind of thing. And if we don't want to mess with the chain rule, let's just multiply it all out. So let's do algebra first, blow it all out, and then we can just go piece by piece. So 16t to the fourth plus, maybe I should write this out. 12t squared plus 12t squared is 24t squared plus 9. Right, or why is that not my answer?
Because you didn't do like antiderivative.
Good. Occasionally people will stop there like, got my algebra right. Like, yes, you did, but we now need to take the antiderivative of those pieces. So this is fun because I get to call lots of names for one problem. Audrey, how about the antiderivative of 16t to the fourth?
16t to the fourth divided by 5.
Good. Yep. Yeah, you guys are right to go slow on these. Don't rush things. Sophia, how about the antiderivative of 24t squared?
24t.
Yep. And yes, that will reduce, but we're not worried about that right now. Let's just make sure we got the rule right. Lexi, how about the antiderivative of 9? 9t. And then don't forget the plus c. Perfectly good answer. Obviously, we could reduce that 24 over 3 if we were so inclined. Okay, what makes... Alec, I'll give you, I think, the easy question here. Not how to answer it. What makes number 5 look different than all the others? It's theta. But the rules are still the same. So, Alec, do you think you could do the antiderivative of theta squared? Yeah. No? What if I told you the rules are still the same? Okay, so what is the antiderivative of theta squared?
Theta is the third.
Yep. Yep. Secant squared. They snuck in a trig rule on us, Claire. Who has a derivative of secant squared? Cosine goes to negative sine.
Oh, okay. Tangent?
Tangent goes to secant squared. So plus tangent of theta plus c. And then, that one looks not great. Leah, thoughts on what we should do with number 6? I mean, it looks kind of like a quotient rule problem, but there is no quotient rule for antiderivatives. So don't start thinking GF prime, that doesn't work. It's a similar step to what we did in number 4. And by that I mean not calculus. Like, what would you do if you were in algebra class and you saw number 6? You could reduce all of those things. So 4x cubed plus 2x squared minus 1. Again, that's not my answer. That was algebra. Three more lucky winners. Sayla, how about the antiderivative of 4x cubed?
4x to the fourth divided by 4.
Good. And again, once you've done a bunch of these, you might simplify that like on the fly in your head, but for now, leave it alone. Don't worry about it. Braden, how about the antiderivative of 2x squared?
2 or 3x.
Okay. Yes. You put the 3 first, which is fine. Increase the power by 1, divide by 3. Evan, how about the antiderivative of minus 1? That's just negative x. And Zach, why is that answer not right? Not quite right. Plus c. Obviously, I could reduce the 4 over 4, but don't need to do that. Let's see if we even need to do those next two. yet. Yeah, we do. And we got time. Solve the differential equation. That sounds fancy. F prime equals 4x squared, given that f of negative 1 equals 3. Okay, well, if f prime is 4x squared, then let's think backwards. I'm going to get to everybody here. So, Avery, if the derivative is 4x squared, I want to underivatize that to get back to f of x. So what's the underivative of 4x squared?
4x cubed over 3.
Good. Well, almost good.
Plus c.
Plus c. Maybe we should have backed up here. Solve the differential equation means find f of x. So it doesn't mean solve as in find x equals 3 or x equals 7. It means solve the equation, find the new equation. So I've got c, but this time they gave me some information that I can use to find c. So that means if I plug in negative 1, I'm supposed to get 3. So 4/3 times negative 1 cubed plus c equals 3. So you plug in the point to figure out what c is. Let's see, so that would be negative 4/3 plus c equals 3. C equals 3 plus 4/3. I mean, we're all about safe stuff, so if you're worried about adding fractions, leave it at that and be done. I'm going to clean it up a little bit. That would be 9/3 plus 4/3 is 13/3. So now I know that my function is 4/3 x cubed plus 13/3. So what makes 7 and 8 different is instead of leaving the plus c, you figure out what c is. Okay, number 8. Solve the differential equation. The second derivative is sine of x, given that the first derivative at 0 is 1 and the original function at 0 is 6. So Helen, what are we going to have to do on this thing? Or what makes 8 different than 7? Okay. So what do you think that means in terms of what we'll have to do? Perfect answer. We'll have to go backwards twice. So I need to go backwards. Man, that's everybody. So what's going backwards from sine? Who has if the answer is sine, what was the function whose derivative would give us sine? Negative cosine. Plus c. Okay, that's backwards once. That gets us the first derivative. You could go backwards again and then have two c's, which would be a mess to deal with. So most people will pause right here and figure out what that c is, because I have some information that will help you do that. If I plug in 0, I'm supposed to get 1. So negative cosine of 0 plus c equals 1. And everybody knows that the cosine of 0 is 1. So negative 1 plus c equals 1. C equals 2. So now I know that f prime of x is negative cosine of x plus 2, because now I know what c is. But Helen was right. We got to back up 2 steps. So we finished with the first step. Now we need to back up one more time. Looking around, yeah, I called on everybody today. It's a good day. So how do I go backwards from negative cosine? Negative sine. Oh, let's just run it back a little bit here. Claire, how do I go backwards from 2?
Plus 2x 1.
Yeah, 2x to the first. Yeah, that's fine. Right or why am I not quite done with this statement? Plus c. Now I need to use that equation to figure out what c is. Oh, this is maybe a little bit weird because I've used c twice and they probably don't represent the same thing. So I'm okay with that, especially since I solved for c and then I kind of started over. If it bothers you that we've got 2 different c's in there, then some people will start doing c1 and c2. But since we clean it up and then kind of start over, you're probably fine with just using c. Okay, negative sine of 0 plus 2 times 0 plus c equals 6. Oh, well that's pretty easy because sine of 0 is 0. 2 times 0 is 0. So c equals 6. So my grand finale answer is negative sine of x plus 2x plus 6. Okay, I'm going to pass out the worksheet packet. Friday we'll assign worksheet 1. Monday we'll assign worksheet 2 with no notes. Tuesday we'll assign worksheet 3 with no notes. So like this notes set goes with all of that because we just need practice going backwards. It's just practice, practice, practice. There. No, because solve the differential equation means find f of x. And they gave you some intermediate information to help you get there, but once we find f of x with all the pieces, that's what it's looking for. Okay, I can tell by some of your worksheets that we're not doing stuff as we go, and I get it, you get packed up and stuff piles up on you and you're involved in all sorts of stuff, I get it. But man, you really need to practice this stuff day by day. So I'm begging you, I'm pleading you, that over the weekend sometime, you look at worksheet 1 and do some of it, at least some of it. Don't wait till the end. Don't be the person that just copies the answers down that I've posted. Like, you've got to practice backing up, right? Once you practice, you'll get familiar with it, it'll become easier, and then the test will be easier. If you put it all off, then that's when things don't work. So, as best you can, keep up with things, and that makes it easy to study the night before. It makes it click in your brain rather than just trying to memorize stuff.